Yeah, so according to the schedule we just came up with, we're going to start with Apple stuff, which will probably also take the longest, by which I mean like half an hour. Yeah, so it's not really going to be very technical because it's kind of a press release, but it's also a technical press release. So we're going to cover two articles. This is one and this is two. And I actually mostly care about the two because like I really do trust this. Like I really do think it is the most advanced security architecture ever deployed to cloud compute at scale. But like this serves as a useful way to foreshadow it.
Okay. These go for by Apple.
Yes, so both are Apple, both are released like a few days ago. Yeah, so June 10th. This is, I think, day one of Apple's WWDC. Yeah, so like if you've been following press releases, you might have seen that Apple introduced a bunch of like AI integration with the operating system, and they announced OpenAI partnership and stuff and things. And we're going to skip responsible development and talk about. So this paper talks about some technical details of how Apple's machine learning stack works, which I think is just useful to see how industry leaders do their machine learning and like in which direction they take it. And this is going to be advanced security architecture, something. So Apple released two models. One is an on-device model. It is a 3B class model. One is like a server class model. I think its size is unspecified. So when they talk about how they trained it, they're basically like, we used our custom framework, which is basically aligned with industry standards, and we use all the industry standards to be like efficient while training. I think this is like the most important keyword here, but I'm not going to cover it. It's basically a nice way to pipeline training so that you don't have like free GPUs when doing it like forward backward passes. I mean, if you normally to do a backward pass, you might get that like you did a pass over some data, and like this GPU is now waiting for other, and this is what it shows. Yeah, so like industry standard techniques, and they're like, also we need quality, and so like we filter the data quite heavily to have quality. And this is how we do foundational models. To do something on top of a foundational model, we come up with two like whatever algorithms, like mirror descent, leave one out, advanced estimator. Like we come up with like a line's worth of machine learning buzzwords, 1 and 2. And like, yeah, so this was like foundational model. This is RLHF. And this is the actually interesting thinking is actually interesting bit, I think, which is engineering. So engineering the model to fit into an iPhone. And again, we start with basics. Grouped query attention is something which is used in Llama, I think. Then we do something interesting. This is like, anyone heard of low bit politicization? Yeah, I thought so. I haven't either. So here is what politicization is. So it's kind of like similar to quantization by intent, but the idea is that we take the model weights, we we take the centroids and like we and we make a lookup table of centroids, and this has like interesting compression properties.
What is it, centroid?
Centroid is like you have a cluster and you have a central.
Oh, okay.
Yeah. So I mainly point this out to highlight like the real computer science you sometimes see beyond machine learning, like beyond applied machine learning.
So this is basically like quantization, like lookup thing for weights, but fancy.
Yeah. Then they do actual quantization. So this is, again, like, this is a little bit ahead of industry standard. So like, for instance, in Bedlama, we're currently using LoRa quantized to 4-bit. And this is a mixed 2-bit, 4-bit quantization, 2-bit for less important bits, 4 bits for more important bits, which is like good, but like a little bit ahead of mainstream. Then they have a pretty fancy tool they have for exploring model behavior. This is, I think this is the right thing. Yeah, so you might actually have seen something like this. So like you have a modeled graph, and for each layer you have its for each layer you have how many watts it takes on a device. Yeah, and you have like parameters like sparsity and quantization, and you basically like poke you like and this is your whole model architecture, and this is data flow, and like you oh, and this is how much time the model spends in computation. So it's like a profiler also, and like you try to poke at this thing to optimize for latency and power. Okay, that was Talaria. And they claim impressive results, like 30 tokens per second on an iPhone.
How do you poke the model with Teleria if that's like 2 minutes answer and not 30 minutes answer?
Well, basically, like you change these columns.
Oh, so you change like how much hardware each layer like has or something like this.
Yeah. So
okay.
like you might quantize a layer like so, or you might try to distill this whole block into a simpler block. Oh, I mean, supposedly. It's not like I used Teleria. Right. Yeah, so, and this is pretty impressive. Perhaps this is even more impressive. So this is like, like GPT-4 used to have like a long like startup time, right? And this is also startup time. Okay, so that was engineering for low power and for like handheld devices. Then they claim something I haven't actually seen in production before. So like everyone knows that when you have LoRa, you have like this LoRa adapters, and you can hot swap them. Like you have foundation model, and you can take like I don't know, like an essayist LoRa adapter and like plug it on, or you can like take it off and like add like a mass adapter. Like this is well known, but I haven't actually seen people use that in production much. Maybe I'm just not aware. And Apple is saying that they're using it in production on device. So here is here is a bunch of adapters like email replies, like Siri, like summarization, editing.
So these are just like different fine tunings.
Yeah, and these are small, so each of this is like 20 megabytes, and you just like add them on top of the foundational model. I mean, you just like some activations at relevant parts. Yeah. Oh, yeah. And what's interesting is that I think they are saying that they also have like a small model which decides which adapter to use. So it's like, like an auto configuring system. Yeah. So they basically dedicate 2 pages to plots on which we don't know what axes mean. So I suggest summarily skipping them. So like proprietary benchmarks where they do very good. Yeah, just one thing I wanted to mention is that so Microsoft also does this, as in they also do a small on-device model. I think this is also quite heavily connected with Windows 11 AI laptops thing. And Microsoft model is called Phi. And they're saying they're better than Phi, and I'm inclined to believe them. Benchmarks. Oh yeah, and that's the thing. So any questions about this? All right. As then we can go on to what I actually want to talk about, which is the private cloud computing. Yeah, so I had a bit of a challenge when annotating this paper because like it's very dense and it seems like most words are actually useful. Yeah, so I wonder how close we will get to like actually just reading through it together. Let's see. So like I think the basic narrative is that so apparently sometimes companies think that collaborating with law enforcement too heavily is bad for business, right?
Collaborating with one person to do what?
Collaborating with law enforcement too heavily, like just like spilling it all to law enforcement. Like apparently, maybe I don't know, customers don't like that or something. I don't really know. Yeah, so for some reason, sometimes companies think that apparently, and this is how and this is why like Cloudflare touts like zero trust networks. So like connections encrypted everywhere, even between data centers, so that you can't just like tap into the line between data centers and like get all the traffic. Or like Apple's marketing strategy centers upon like an iPhone being a secure device, which it takes very special effort to extract data from. So like police find it hard to extract data from an iPhone, stuff like that. So, and historically, cloud has been like a thorn in that agenda because cloud is someone else's computers, and when like the computers are someone else's, then like like an FBI officer comes into a data center and is like, "Can I have these SSDs, please?" And like, I mean, they have to comply or something. And they introducing a scheme here to make a cloud very much more secure than is usually the case. And like, let me go through a bit of a paper and then get back to my commentary. So, like, which particular issues are they highlighting with like state of things in cloud as they are now? Like, cloud providers often say that they are military grade secure and absolutely do not lock customer data. But like, I mean, a developer can just push an update to production which logs data because it's useful for them to debug a problem, and then like you're logging data, and and when you're logging something, you might backup it, and like this can persist for like 10 years easily. Or like, like a network a network ops person wants to debug load balancing, and they have this TLS terminator, and they also just log requests.
This is your manage for that like this, because if you are old enough to remember the code, because TLS is added only here, you can go with
What's the words again? Okay, sounds fun.
This is actually a bombs now of them.
Yeah.
What?
Yes. So you have public internet, and you have Google Cloud, and like a Google front-end server is something which adds and removes SSL. And like there is no SSL here or here.
Okay.
Yeah. So like the point is that Google's internal traffic is clear text, and this is Snowden. Yeah. Okay, so that's issue one, and like the way they frame the issue one is that like a cloud provider can say many things, but you don't actually have a way to prove them. The second is basically the same. So like a cloud may run some code, and the provider might tell you that we are running this code and it's totally open source and everything, but you can't really prove that they are running this particular code because they're just running something. And also, like, so these days, clouds typically have like maybe good access control, like, I don't know, you can log, like, I don't know. So like a startup might just have, in a startup, a person might just have direct SSH access everywhere. And in a cloud, they probably have like keys provisioned to their directory ID, and every like key retrieval and login is logged and everything. But still, like, I don't know, an incident occurs. And so naturally, an administrator like SSH is everywhere. And this is basically an uncontrolled situation. Yeah. So like you're backing up data from a live server, you can easily back them up like to your local flash drive as well. Yeah, so, and you basically don't have this with local devices. At least, I mean, like with local devices, you have, I don't know, like you have, like for instance, with Android, you have Play services being essentially a remote root exploit, but like any kind of exploitation of this kind is much more visible to researchers because it's much easier to audit, like because there are labs like auditing phones and like trying to figure out what they do, and it's much harder to do in cloud, and we have much better research for endpoint device. Yeah, and a little bit like of an interesting tidbit I wanted to say here, the link in the blue link. So data protection file encryption system. Apparently, on iPhones, when you create a file, you automatically create a 256-bit key. And like each file has its own key. And I am mostly impressed that like you can do that with acceptable performance. Yeah. And like for completeness, macOS does something else. On macOS, you have like a volume wide encryption, so like just standard full disk encryption, and you have this like file saying opt-in for DevOps. Yeah, and so we're like, okay, end user devices are cool, but we still want to run 30B models, not only 3B models, and like, how can we restore some useful guarantees from a server? And this is somewhere I'd like to like go back to my commentary for a bit. So you probably heard of Signal. And Signal had like a challenge. They wanted to be usable but also secure. And they're like, every messenger out there has a contact directory because like people find it useful like to import the phone contacts by phone number and like know who's on the messenger. But like if you just do that, then you open yourself up to like to all kinds of attacks, like finding how a person is called in a particular person's contact book, right? Like you know like how secret services how low rank secret services agents are de-anonymized. Yeah. Yeah, so it's kind of a challenge, and you can basically solve this challenge. Like you can think of solving this challenge in two directions. Actually, maybe more, but like without compromising usability, there are two directions I can think of. One is you come up with some crazy crypto scheme, and in this case, the crazy crypto scheme is probably like something in the direction of yeah, I'm not even sure actually. Yeah, so if you don't have a bootstrapped root of trust, you only have like a phone number which is easy to guess, so you don't really have a shared secret. Yeah, I'm not sure. Like you don't need no way to bootstrap a crypto scheme from here, I think. Though you might be able to do something like so there is tech to for example, there are algorithms to if you have two vectors to get a dot product of the vectors without revealing the vectors. Yeah, so like only leaking a small amount of bits, not the whole vector. And I think you could do something in that direction for contact books. This is one thing. And there's also another direction, which is less crypto heavy and more engineering heavy, which is to be able to prove that you are running this particular open source code which people think is secure. And Signal went in the second direction. So there is something called Intel SGX, also, no, not this kind of SGX, which is basically the non-brand name is Trust Execution Environment. The non-brand name, so Trust Execution Environment, the idea is that you have your CPU and you have a coprocessor which is trusted, at least as much as you trust Intel, maybe more than your cloud provider. And what the TE can do, it can do, you can ask it, TE, what code are you running? And it can tell you, hash this. I mean, like this hash. And this hash is signed by its built-in certificate, which is in turn signed by Intel. And so you have this chain of trust. Yeah. And this is what Signal did for storing contacts. And now, and like you have a few engineering challenges here. Like if you have a coprocessor, then you have to make like its memory and its computation isolated from like the standard processor. So like it can't just copy its memory out to something. And you have to design its API well and like stuff and things. But basically you can make it work in SignalDit. And what this paper is about, it's about Apple doing the same thing, but for machine learning. So yeah, here's a bunch of like, this is the rota. So objectives they wanted to achieve in the design. So first off, they want to be stateless. So like request comes in carrying all its data, it gets processed, gets out, no data is stored, no one, and we have like, it's not exactly end-to-end encryption, but it's like, so data isn't available to any agent except the user. So like agent and this like execution environment, I mean user and the execution environment, no other people.
Okay, but if you send a request, then the data is available to whatever you send the request to.
Yeah, the idea is that this is this picture. Only we move the terminator to the very end. So like we don't terminate at entrance to data center. We don't terminate at the server.
Oh, okay.
We terminate at the GPU
Not
basically.
available in terms like not encrypted.
Yeah.
Okay.
Yeah. So like terminate at the GPU is a good way to think about it. Yeah. So stateless. Just Dota 1. Enforceable, which basically means you have like a strong threat model under which you can't break it. I mean, and we don't like a model with people who have to be good, like system administrators who have to be good. Yeah, so like we want something which works independent of our staff's intentions. To enforce that, we want to not have any special access interfaces, so like no root access. And the next thing is quite special. So for some systems have this property that you can compromise one user without compromising the whole system. For instance, you can do a SIM swap this way. So you bribe a telco's stuff, and they give you a SIM card for a particular number, and like you didn't break the telco, but you broke one particular user. And they don't want to have this property. Oh yeah, and maybe another example from the paper. So like imagine a standard cloud. So like you have database replicas, and it's only sufficient to take away one database server because they are replicated. Again, like they don't want this property. And this should all be like verifiable to third-party people. So not internal Apple stuff. And like this is very strong. Like this is super strong. Like no one does this level of strong.
No, I just thought my notes there at the bottom.
Yeah. It's top actually.
I mean, it is bottom of the page.
It's top of the screen. Yeah, so, and this is how they do it. They like basically build a new custom compute node which like, so like the way I read this is as follows. We have a computer with a hardware-enabled boot chain. So like we can only boot on like we have very minimal firmware, which physically is hard to tamper with on the motherboard, or like probably in the CPU. We have very minimal firmware, and this firmware at each step of boot checks that what we are booting is signed, and this is secure boot. Then we have secure enclave, so we have this trust execution environment thing. And we have a very small system, so it's a hardened subset of macOS. And this system can only load code which is again signed and which is sandboxed. So this is a little tiny bit like Kaspersky OS I was working on at some point. Yeah, so like custom narrow targeted hardware, custom narrow targeted operating system, small attack surface, no SSH, no general purpose administration utilities, only special built utilities which like provide a few things in a hard-coded way, not many things in a flexible way. Yeah, so we have a bit of an elaboration on that. Let's maybe try to get through this quickly. Any questions about this so far?
Something about policy.
I mean, it's not like this technology is special. I mean, you could have a desktop which works like this. You could have this compute node at home, but it probably wouldn't be useful as a desktop because it's too secure to be usable. I mean, like, for instance, in Kaspersky OS, we used to have, like in many secure operating systems, you don't allow processes to be started dynamically. So like all processes are like built into the boot image, and like they start when the system starts, and that's it. Yeah.
So now, is there anything specific to like AI, because it was titled with like AI and machine learning and stuff? And
yes, that's a great question. So I think
does that sound like we should do all cloud like this?
Yes, I think they don't actually say this here, and this makes this question even better. So why doesn't everyone do cloud this way? And to get more of an intuition, if you like, I invite you to read Signal's write-ups on that. But the point is that this has a very special programming model, and it's hard to fit general purpose logic in there. For example, Intel SGX has a grand total of 256 megabytes of RAM. So not gigabytes. And it's also slow because it's like a tiny small coprocessor to like an i9 or something. And so you basically have to do very special programming there, and it's hard to do like to fit general cloud scenarios in there. But small narrow scenarios like signals contact books are okay. And I think what is really special like about this work is that they realized that machine learning is actually a very narrow use case, because machine learning is multiplying matrices, and it's very narrow. So like a really good way to think about this result is like you have Google TPU, right? Tensor processing unit, or like a GPU, and this is like terminate user requests at the TPU directly. And the TPU can prove that it is running this particular code. And one of the things they do here is that they, I think it's release, and they release all software they deploy in the PCC scheme publicly. And they have a transparency log similar to TLS. And yeah.
Okay, nice.
It's not how they debug this so high in the environment. How do they improve quality? How do they measure quality? That's that.
Yeah, so I think this, like, again, I think this only works for extremely narrow use cases. And like what they basically have to do here is like make sure they multiply matrices correctly. And this is a pretty well-known like problem. So like
They multiply right matrices, but the question.
yeah, so I mean, one intuition I have about this from microcontrollers. So sometimes in microcontrollers you have like, when it comes out of the box, it has debug mode turned on, and like you can like read, write a bunch of stuff and things. And then you can, and it has like a few fuses, and then it just blows the fuses, and after that it has no debug mode anymore. So this is one way to do this.
Still like to achieve to improve quality, you need to measure something. And if you have a quality, you probably need a lot of data. I might see about the story that's maybe they don't even measure things, and they just trust the models that they have first.
I see. So I think you're coming at this from a software mindset, and what they're actually proposing here is hardware. So this like this paper is about how they do private inference. This is not about training models. This is not about evaluating models. So I think what they do in practice is they like train the models in the usual ways, and they do like human evaluation in the usual ways, and they probably have like alpha testers, whose AI requests are routed to standard servers, from which they collect a bunch of like data. But this is just this is just a hardware accelerator for AI inference with like remote access, like direct to users. So it has like few moving parts.
Basically, they say that they throw away lots of data they can use just for the customers to be sure that can actually made just.
Yes, and also, so Apple actually has kind of a solution to this. I don't want to discuss it in detail today, but they're saying, so I'm not sure how it applies to this exactly, but the way that Apple generally does like statistics and collect user data is via a statistical framework for anonymizing data. So they collect all data on device and anonymize it on device with this statistical framework and send like aggregated metrics. So even prior to PCC, they tried to avoid collecting metrics in the cloud. Yeah, so I expect they have some answer in this direction for your question, both like how to collect metrics in a private way. And this framework is pretty robust, and we actually had a seminar about this like some weeks ago. Yeah, right. So any more questions about this result?
Is it some work in the process, or in the process, or it is something that they already released?
Yeah, so I think this is currently in alpha, and it's going to be in beta in like a month maybe, and it's going to be full production in well, when next stable release of iOS and macOS comes, which is less than half a year, so a few months.
Yeah, I think they released like on what versions like of iOS, macOS, iPadOS, whatever they have, they will already have it.
Yeah, so
I
this
think they're just waiting for the next.
exactly. So this is like iOS 18 and macOS Sequoia. So next releases.
I think they also said that this thing will only be available on like all only US like flagman devices. Yeah, they just to it's the same. I think it's only for like the latest.
Why?
I don't know. I just read it. Maybe it's wrong, but it's just something that I remember.
Sure, I think it's related for neural processor in the one and sensor processors.
Yeah.
One is not like
Yeah,
it's a fragment, but it's those neural processors. Starting is switch to series.
Yeah, and also the like M1 series is used in this as well, because this gives Apple their own secure boot chain. So like not Intel's secure boot chain, but Apple's own secure boot chain, and also Apple's own secure enclave. Yeah. Yeah, so I wanted to talk about this because I think similar to the Anthropic result we covered like some days ago, this was extremely unexpected to me. Like, I mean, I was sure that better hardware-enabled security for clouds is a good idea, but no one seemed to be doing it because no one seemed to care. And then, like out of the blue, 3 days ago, Apple releases to production basically, and I was just impressed.
I think Apple has some reputation for protecting data, like being there protecting as well.
Yeah, sure, but I mean, like,
it's like just jump from 0 to 100.
yeah. So like they say a few times that like this is the most advanced security architecture ever deployed, and this is actually true. And like mostly when you read this kind of claim, this is bullshit. This is not bullshit in this case. Yeah.
Apple's also known for secrecy, so they probably worked on it for a few years.
Yeah. I would expect like this to have been designed for a few generations in Apple Silicon. Sure.
So I still don't get it.
Yeah.
How can like random person check that it really works on this particular hardware? Secure way.
Yeah. So, so imagine a standard CPU, and the standard CPU has like instructions like move, like add, right?
Okay.
And this special CPU, which we call a trust execution environment, basically like on the CPU level, has a trusted network stack, and has an instruction, tell me what code you're running.
Yeah, I get this part, but I don't understand how to check it. If they really have this hardware in their.
You mean how to check with Apple? And
Yeah, I mean, how can I check that they are really running it on this particular processor and not just a processor without?
Right. So you have. Yeah, so the question is how to check that this is running on a trusted execution environment and not like a normal processor. You have so like let's like take it in two steps. Step one, I build a secure processor and then give it to the cloud to host it. And because I built it, I also built in a special secret inside, but better yet, like a formula, like, like, I don't know, like my request XOR secret, right? And this way, like if you also have transform security, I can know I'm talking to my thing. As long as I trust my thing. Is it all right?
Yeah, but there should be some first party who
Yeah.
is not Apple. So we should be sure that Apple doesn't find some.
Yes, this is a good point. I'm not sure they cover it in this write-up. I expect them to cover it when they release more complete documentation. One of the things they do is yeah, so I expect them to do something like, so like the basic design is you have a certificate authority and each processor has like a certificate, and I expect them to use some sort of like transparency log, like on this day we issued this certificate for this device, like installed in this data center, and like if anyone finds a weird inconsistency, like in this scheme, you also often have like someone checking, like someone trying to connect to this device from America and from Europe. And like if they get like different certificates, they're like, oh. Yeah, so this is at least what they could do, and maybe they're doing something stronger.
Okay, thanks.
Any other questions?
What would you hack for? Which is the
Yeah, so
any suicide?
right. What would I hack if I wanted to hack it? Yeah, so I think like hacking this directly is quite improbable. And maybe the best thing you could do is to try to hack the supply chain. So like they say that they're releasing every production build of PCC. I'm not sure what they mean exactly. Like they might release binaries or they might release sources. And like, so one thing I would do is I would try to poison the supply chain, the software supply chain of PCC. Right? So like introduce some weird bug in some like cryptography library or compiler like down the line so that it eventually comes down into this build. Then I might try to smuggle. So like I would try looking at what the load balancers are doing, because like they probably have something which switches like alpha testers to normal servers and like production to these special things. So actually, I think this wouldn't work because one of the things they're doing is that user's device checks that it connects to this thing. Yeah. So the next thing that comes to mind is to try to hack the user. And this is probably the cheapest thing, actually, because you can just pay Pegasus.
Yeah.
Or, I mean, like, even better, like, hack the user's hotel bedroom.
Yeah, I want to say that probably to pay someone to like knock the user out is like the cheapest version. With unlocked phone in your hands.
Yeah.
Sure.
But like, I just wanted to highlight that this is actually this actually moves us in the right direction, because yeah, because this because like when you steal like a whole SQL server's worth of a database, then like your cost per row is like, I don't know, cents, and paying someone to actually like go somewhere is at least $2.
Do you think that developing more secure cloud actually endangers the users more? Because we arrived at the idea of knocking someone out like in 2 minutes after reading BCC.
Yeah. I do, but also I think this still moves us in the right direction, because if people get assaulted more often by the government, then maybe people will stand up for their civil rights for once. Great. Yeah, so I think I'm done. I suggest taking like a 5-minute break.
Okay, so this is Bartholomew Thoughts paper suggested by the person who's absent today. This is going to be quick, at least I hope so. So for LLMs in general, we have different techniques to kind of get better output without doing any actual like engineering or like email things, like basically better prompting or some like engineering around the model. And supposedly this paper like explores a new technique called buffer of thoughts. And they write that it is novel and is versatile and it is better than everything else. They conduct extensive experiments on 10 tasks and achieve some significant performance. So we're going to see into that. I'm kind of sounding very skeptical. There are parts of that which are, I think, have some like reasoning behind them, but also I think that some results are kind of, I don't want to say fakey, but yeah, we'll see them. They're not sus, but it's like they give some results, and this often happens in like ML papers, as I noticed. They give some results, and then they interpret them in a way that like favors their point of view and not in terms of like what they actually show. So this is, I think, a nice scheme of like what are current methods for querying and like trying to get an output from ML models. And the most basic is here at the top. It's just single query. It's manual prompt. So this is how you usually operate with like ChatGPT, for example. You just like type something in, you get a response. There are ways to get a better response, for example, using like common prompt techniques as few-shot prompting when we give some examples on how to do the task to the model, or when we do this like, I will pay you $1,000, or like, please think carefully and like outline each step, and so on and so on and so on. But the idea is that we just like have a single shot, single prompt, we input it, we get some reasoning, we get some output, and we're hopefully happy with that. The next kind of more advanced method is to have some iterations. So what you do is you use this kind of developed query that you did, and then you get some output, and then you take your original prompt and the output, and you put it back into the model and like improve on this, do better. This is called chain of thought, when we just have like a linear chain of like thoughts until we're happy with what the language model outputted. And then there is even more advanced thing called tree of thoughts, when we have not like a linear just sequence, but when we have like a tree basically. So for example, model generates like 3 variants of answer, and we were like, let's explore this one. Or like, oh no, we actually don't like it. Let's like backtrack and do like another exploration. So we like explore the tree, and at some point we hope to arrive at like a good answer. And they say that this is all low efficiency, a sad smiley face. And the happy smiley face happens when we do this buffer thoughts thing. So the idea that they put behind that is like, basically that we as humans, when we think about problems, we often have some like already learned solutions for them that we like reuse. So for example, like we learned how to solve quadratic equations, and then when we encounter another problem about quadratic equations, we like recognize them, and we don't do this whole thought process again and again. We like have them cached basically, and we like extract them, use them very efficiently, very nice. Okay, so that's what they propose. They propose to have some what they call a meta buffer, essentially just a storage of like already cooked thoughts and ideas, or like schemes on like how to solve the task. And then when we prompt the model to do something, it analyzes what we prompted it with, looks into its meta buffer, searches for like relevant thoughts that it already has, and extracts them and uses them. And it like takes a couple of different schemes. It can like combine them in like a sequence, and that they call this process instantiated reasoning. And then we get the output. And after we got an output, what we do is we look at the output, and we look at the whole reasoning chain, and we're like, have we done that before? And if we don't see anything in the meta buffer, and this is this dotted line here, we like upgrade our meta buffer with like new ideas. And then this whole process repeats and repeats. That's their idea.
Oh, this is basically like WAP.
Yes, this is basically caching. This is kind of all that they really tell like to do. This is RAG, or like caching of ideas. Basically that. Your laptop is super dark. How can I make it bright? Oh, okay. Is there something new to this? There are a few things I wanted to show extra. So this is like an example of how it works. They have this buffer of thoughts. So they have thought template here, thought template here. They give examples of chain of thought that like doesn't do good. Plan and solve doesn't do good as well. And this does good because we have template T1 here. Oh, yeah, sure. So we have a template for like solve any quadratic equation, and we give it the task Where's the task? Oh, the task is here. Mol sells something like 4th grade math task. And then it's like, oh, I already know how to solve quadratic equations. And it takes this thought template and instantiates reasoning with it and basically uses it and gives like a correct answer, supposedly.
The idea is when we encounter a problem, we try to find if we have like but in this case, they call it problem distillation because this is about recognizing that this free-form text is actually a 4th grade math problem, which is solved by solving a quadratic equation.
Yep.
And we do have like a template prompt
Yep.
for solving a quadratic equation.
Yep. The idea is that though these prompts, as far as I understand, they're not like manually inputted. The model just generates it themselves when you like when you use it over time.
This kind of sounds like decomposition, right? And you take this concrete problem and you try to break it down in terms of abstract, well-known problems. It gives you a prompt.
I think it's kind of, it does sound like decomposition, but from some point of view, it's like reverse decomposition, because instead of breaking down the problem into smaller tasks, we take a specific problem and we're like, what's the abstract version of this? And we hope that we have an abstract solution in our buffer of thoughts. Good. How do you extract something from a buffer of thoughts? How do they solve this problem? That's it. They just generate embedding of the thought template, and they like take the embedding of the current problem and like compare them. If they're near each other, then we like look at it and see if that's relevant. And yeah, they have some thresholds here set for it, but basically they just calculate embedding distance. That's it.
Wait, so like
Yep.
they calculate embedding of inputs and just embedding of inputs.
Yes, by calculating embedding similarity between the description T and
The student inputs, whatever it is.
Yeah, I mean, so the model takes the input, it tries to make it more abstract, and then they calculate the embedding of this. And for each thought, they have, I think I have examples of thoughts here. Somewhere. Wait, I think it's down there. Yeah, so this is an example of how their thought template looks like. So they have a task description and then a solution description and then the thought template. So they calculate embedding of task description and compare it with the distilled, like abstracted version of the prompt. And if they're close enough, they're like, that's probably the solution for it. It kind of confuses me that the task description here is so specific and like about penguins. But I guess it's abstract enough. Yeah, so there's a bunch of graphs that are not really interesting, I think.
My minor focus is trying to find like to spot which software they use to make plots. I think like especially the ones below kind of look like Excel.
This one?
Yeah.
Yeah, maybe.
Yeah, this
is Excel, yeah. It looks like Excel. What are some interesting things that we can get from here? So, what I think is kind of a good idea. So we have RAG. A lot of people know about RAG. We're like extracting like documents or like some help form model is great. What I think Buffer of Thoughts is just RAG paired with some sort of like caching. So maybe for some problems, I'm not saying that. So what are the obvious limitations of this approach? For example, they say that it outperforms. Outperforms in all tasks, all other like methods of prompting, which I don't find realistic, because when you just so at the beginning you have your buffer is empty. So there are two options. Either they manually solved all tasks, inputted thoughts into buffer, and then launched the model, but then this is like absolutely useless because you already solved the tasks by hand. Or what they did is they were like, okay, let's give model like 20, like, let's solve it like 100 tasks of game of 24. Yeah, and then like solve one more. But that makes it kind of really. So this method is only useful if you have a like a model or a system which solves this very similar tasks a lot of times, or kind of related tasks a lot of times.
It doesn't seem like it can't scale. Like you can, like you can do like just a vector lookup on tens of thousands of examples.
Yes, but first you need to run all those tens of thousands of examples.
Yeah, like you can run a production system like that and collect them all the time.
Yes, you can that for sure.
So one thing I'm confused about is like whatever these benchmarks are. Like
These ones?
yeah, they have like a penguins benchmark. Actually,
I don't know. I guess penguins is the one thought that we saw. But they have actually. So yeah, we can check where they got penguins. Yes, I know. Just they list their datasets here, but I don't think penguin. Oh, yeah. Check penguins. It's some big bench suit.
right? Yes, I know what big bench is, but oh, okay. So
Penguins attributes based on a given table. So it's table lookup task. So I think that the cool thing about that is that like we should think about if we should cache some answers from models and have them. Maybe it is useful for stuff like decomposition, or maybe we can use it in some of our projects where we can like, if we do kind of similar things, we can like pre-cache them and improve our performance, which seems to be another nice thing is that this approach is like seems very trivial to implement. I mean, comparatively, but not too hard. So maybe it's another just way to improve performance. And also, I think that nothing restrains you from using this and tree of thoughts at the same moment, which can boost performance even more without actually like having to train a new bigger model or like doing something computationally expensive like this. Is there anything else I want to tell about this one? Not really, I don't think so. If anybody has any questions.
Yeah, I have a question.
You go.
Do they tell how exactly they choose which sorts to cache?
How exactly do they determine which spots to cache? Yeah, I think they had a line about that. Yeah, so what they do is they take the answer that the model gave you and they check if a thought like this already exists in the cache. And if it isn't, they add it. So they don't actually check if it's important or not. They just cache everything that they can.
Then I'm confused about the thing. Why the cache sorts are better than what a chain of sort version generates?
Could you scroll up to the set phase?
Yeah, sure.
So I think the point is that, but at the top we have like low accuracy, and in the middle we have low efficiency. So if you just take the middle thing and make it efficient, then they're good.
Okay.
So this is like basically cache zero slot.
Yep.
Like because you have multiple hops zero slot and you cache like the best hop.
Yeah. Well, thank you.
Okay, anything else? Any comments, ideas, questions?
How do they? What was one of the still have to do they want?
Problem distiller, this one?
Yeah.
Uh,
Themselves to make an abstract version.
yeah, basically. I don't know if they use the same model or they have some other model, but that's what they do. Yeah, it's not manual.
It's just what okay.
So I have kind of comments. So like this line of work in like inline has maps to like to like random agent design literature, which like proposes some like random combination of like model calls and like like lines and boxes and also a cache here and evaluate some penguins. Yeah, so I think like my intuition is that this field is currently in a bit of flux. Like it's very easy to come up with a design, as to say, and so like everyone just like comes up with a particular combination of boxes and calls it something of sorts and publishes. And it's not really clear at this point which works or which one works on languages.
Yep.
And so I like my primary commitment to this was to just like go through the process of understanding like go through back together.
Yep. Okay. If nobody has any other input, I think we can kind of finish. I mean, my main takeaway from that, outside of like use caching when you need to cache something, is like just one more example of that kind of research, evaluating some benchmarks and claiming that they're the best without actually telling like what they measure, how they measure. Like they tell something, but like we discussed, it's probably not. They have not run it in the same kind of way that they run a tree of thought or chain of thought. Without giving like what are the trade-offs, how long this is to like accumulate this buffer and so on. So then I think that's the main thing that I wanted to show.
Don't you think that this approach, like chain of thought, this one
Yep.
will be so example will be obsolete in real.
What do you think will because models will just do it intrinsically?
Just the models be like doing that itself, the matrix multiplications and synthesis without all this
I can like why chain of thought works is because we essentially just give model. So how current models like based on transformers work, they not only take your input as a prompt, but what they have generated, they also like put it into themselves as they like output new words. And what chain of thought does is basically gives them like output more, and they have like more time to think about stuff, and that's the main reason why it works. The tree of thought, on the other hand, if we do it like engineeringly and just like do more requests to the model, this is the trade-off of like how many tokens are we willing to spend to get a task done. And I don't think that this methods will become obsolete. Like, I don't think that something will fundamentally change in how transformers work with just scaling, if nothing new gets developed. That method of just throwing more tokens at the problem will stop working.
I don't know, other methods that allows to more compute, like throwing.
Yeah, sure. I mean, there might be other methods. Yeah, sure. That's
and then the situation of the AI, so that
no. I agree. There are a lot of different approaches. Like Dima said, there are like new paper every like day on like new combination of boxes. Yeah, that's true.
That was not about transformers or some other patient transformers.
Yes. Okay. So I pass the word then to the next speaker, I guess.
Okay, so okay, so this paper, okay, the paper about cyber security capabilities of LM agents, especially in exploiting zero-day vulns. I think that this is not highest quality research, but I invite I choose it because they have interesting setup or algorithm. So firstly, they explain related terms and concepts like information security, AI. I think I don't need to explain this, and also. Zero-day vulnerabilities are security vulns that are unknown to public, to people, usually to engineers of software engineers and developers, but they didn't use zero-day. They use kind of one-day vulns because their dataset contain public public well-known vulns from web security. I think first we can move on the dataset. Okay, so they have 15 vulns from web security related to injections, cross-site scripting, and different things. Okay, firstly, I just Googled I reviewed the list of vulns and found that mainly, like only one or two of them require more than junior level knowledge and skills to exploit them. For example, I just Google. Oh, yeah. Yeah, I did it. So, for example, no, I don't Google. Yeah. For example, we have SQLite injection vuln, and when we look at it, it's actually the most basic SQL injection that you can find. They have some login page, and you have a password, and you need exploit this password, inject your SQLite code, and actually, yeah, you can just run SQL map and it will crack it. And also, when I Google another vulns from this list, I found the same thing. For example, take this one, and when I Google it and review, so yeah, we have cross-site scripting vuln, and what we need to exploit this, we need insert script, alert script, and also this is very basic type of cross-site script vuln, and the same thing we have with okay, so I think only like 1 or 2 vulns here require more than junior level knowledge to exploit it.
So you said this is the dataset.
Mhm.
That's the dataset means here exactly. Like, is this what they found, or is this what they trained on?
No, they just use it. Like we have a list of vulns, and they give the model description, code, like, and ask to exploit it.
Is that a single model or is it like a team model?
Yeah. So the setup that they have is
Wait, just a second. So you give the model a description of the vulnerability,
Mhm.
and it has to actually exploit the vulnerability.
yeah. Actually, they have 2 type of tests. First one is without description. The second one is with description. And so we have
It's not like you give the model a software and it has to find this
yeah
vulnerability.
yeah.
You give it a description of vulnerability and it has to exploit. Okay.
Yeah, actually, it's not really their day, but they call it their day. I don't know. So they have set up the interesting thing in this research is that they use 2 type of agent. The first one is like manager. It's like task specific agents, and manager. Yeah, the manager determine the specific task specific agent that we need to exploit some vulnerability, and then we like choose the like cross-site scripting agent or SSTI agent.
If I understand it correctly, like the planner goes through the website and it's like, oh, a login page. I'm like, and it's like whatever login page can log to, like maybe it's like SQL injection. And then it gives the manager like, this is the page, try to exploit the SQL, like try to do SQL injection on the page.
Yeah, actually they okay, yes, it's correct. And they explain it like there is issue with LM agents when you use it exploiting vulns, like challenging with backtracking when you need to test different type of vulns. So they use multiple agents with like different areas of tasks. And so yeah, these agents are designed to be experts some type of vulns in web security. And also they have access to tools, documents, prompt. Also they use some lib.
It's not like listening.
Yeah.
It's like endless browsers.
Mhm. And yeah, also they said something like you have a good data set because, for example, it's like after the GPT-4 learning dataset or learning. So the results is that we have like 80 success rate with GPT-4 with description of vuln. Also we have like 20% of success rate. The left side we have results for 5 like attempts, and the right side we have like one shot test. Also, they have something like well-tested Metasploit and Avast Blab, and they have 0% of success rate. I'm not sure that's a good. It was a good test because we have a very basic vulns. Yep. Yeah, also they explain their success cases and unsuccess cases, but in general, I think that's all about this paper.
Well, I think it's fun that they say that like our like I think like a strong version of the statement will be that even if you can only crack very basic balls, we can still do it at like $4 every round, and like a cyber expert costs like $6 per round. So we are 50% better than cyber expert from Apple.
Yes, I have kind of cost analysis. Yep, here.
Yeah. Oh, actually, they're quite a bit more expensive. 75 actually.
Mhm. Okay, I think we can move on. AI security platform.
So you're using Pirate.
Yeah, probably. Yep.
Yeah, also about this paper, I like the setup because it's kind of related to another work about multiple agents in.
Wait a second. I have maybe also record my mic here. Yeah, go on.
Okay, it's also related to another paper where you have kind of multiple agents with also some task-specific task-specific areas, and they also find that it improves quality and accuracy and benchmarks. Yep. Okay, so we have a kind of capture the flag platform. What is capture the flag? It's a type of hacking game where you have tasks or challenges related to cybersecurity topics, and you have solutions or the flags. The flag is kind of a string or key or solution to this task. So in this platform, we have challenges about AI security. Related to model evasion, and prompt injection things in LM. And how it looks like, you have endpoint for challenge, you have token, also sometimes you have some data to solve it. And also you have like API to model classifier or LM.
So the challenge is to extract data from the model, or is the challenge to poison the model, or
yeah,
all of this?
Yep.
Okay.
And Okay, so there are different type of challenges with different complexity of task. For example, we have tasks related to like like basic data data analysis skills, or like basic AI skills. Also, you have tasks about model extraction or prompt injections. Where you also need to do some security task and find the flag.
I think kind of like the most interesting of this is, can you have the previous page?
Which one?
That is browser history fingers. Yeah. So I think fingerprinting is maybe one of the most curious. So like apparently you're trying to craft an image which can tell you if classifier 1 or classifier 2 is
Yeah. You need to determine like the type of model or something like this, if I remember it. So okay, in general, I think if the question was like, do we need it, or what we can take here, I think the main question is like, do we need AI hacking skills? And probably if needed, we can use it. Okay, also I think like we have free way to use it. For example, yeah, we can. Yeah, we have like free way to use it. The first one is just use it for practice to solve tasks. Second one is use it as part of kind of course with some theoretical okay, with some theory and with these tasks. Also, we can use it in like as a part of more complex sequence, like theory, practice, and our own tasks and CTF platform. It probably depends what we need. Okay, like, do we need skills and
like so like one I think it might be useful to give a bit of backstory. So we discovered that there exists a company which does offensive machine learning, and they do a bunch of things, but it seems like they are more general about machine learning than what they say it is. And like one of the things they do is like it's like adversarial attacks against foolish classifiers, for instance. And so they launched this like CTF platform. And one of the things I was curious about if this CTF platform is close to the idea we had about like an AI CTF platform, like where you have like an agent defender and agent attacker, and like this is like basically like CTF combinations. And apparently it's not. Like apparently it is designed to teach humans how to go around an AI model. Is this correct?
Yep.
Yeah. All right. Yeah. So this answers my question.
Yeah. Okay. Okay. The last paper is papers about retrieving datasets. actually I have reviewed. Okay, firstly, just some of them just don't work like this. But also I have reviewed only first 3 maybe, or yeah, I think like these ones. Okay. Retrieving datasets are datasets with some harmful tasks or goals that you can use to test language models, and you need to find whether model help you with this task. Yeah, so the most classic one is the bench. It contains like 300 500 harmful tasks about in different topics like yeah, like building a bomb, tax fraud, and so on. The second one I think is like a double bench, but but with many specific tasks, like they have some harmful activity, for example, like making a bomb. Also, they have composition of them or conceptualization, like what we need with that. Also, they have some of clarification or specific application of them, like for example, how to make a bomb like somewhere. And yeah, I think it's like the main key point of this dataset. They have more specific harmful tasks than other bench.
Yeah, I think the point is that this allows you to cheaply augment your data set. Like you just like add 100 of locations, and this gives you like 100 times more points to fine tune.
Yep. And the third one, I think, it's like a bench. Okay, it's like a big adverb bench. They have a lot of harmful tasks, like a lot of yeah, and they use different data sets to find them. In the first data set, they use their crowd workers with goal to generate some harmful things about different topics. The second data set we have LM GPT-3 that generate harmful tasks and questions in different topics. So we have a lot of harmful tasks at the end in like different topics, like yeah, like violence, privacy, so on.
So I actually reviewed this one, and I think the 300 number is inflated. So like this is like total pairs and like using annotations, and there is actually like 50,000 unique question answer pairs, but it's still like a lot more than 500 samples of harmage.
Yep. And yeah, in the
Oh yeah, and also another difference is that out-of-bench is like just QA pairs, and BoT tails is human annotations of helpful that's and components.
So also in the second one we have like AI generated dataset. Here we have like AI and human generated, like compilation of them, and another bench also human generated, right?
No, I think it's not human generated. I think they use like some open source LLM.
Yep. So actually, these ones. Okay, I think I briefly read it and found it something like a bench, but I didn't read in detail. So I think that's all of my things to read.
Any questions, Martin?